Welcome to our comprehensive guide on building MCP servers on the Internet computer. Today, we'll explore how to create an MCP server using Rust that runs on the Internet computer blockchain. This powerful combination allows you to build decentralized AI tools that can be accessed globally without traditional server infrastructure. By the end of this tutorial, you'll be able to build a complete MCP server on Internet computer. Here's what we'll accomplish today. First, we'll set up HTTP request handling for both read-only queries and state-modifying updates. Then, we'll implement the core MCP protocol methods: getInfo for server metadata, listTools for tool discovery, and callTool for tool execution. Finally, we'll build a working counterexample that demonstrates state management and tool interaction. This foundation will give you everything you need to create your own decentralized AI tools on the Internet computer network. Let's start by understanding how to handle GET requests in our MCP server. In Internet computer canisters, we need to define methods that can handle HTTP requests. Here we see a basic HTTP request handler function. The first step is to add the Marco query at the top of our function. This attribute tells the Internet computer that this method can handle query calls, read-only operations that don't modify state. Now let's build our response. We start with HTTP response to create a new response builder. Next, we set the status code to OK, indicating a successful response. Then we add with upgrade with argument true. This will convert query call to update call, and it is crucial for MCP servers as it required HTTP post. This upgrade capability is what enables the persistent connections needed for MCP protocol communication. Now let's look at update calls. These are state-modifying operations that require consensus. Here we have an async function that handles HTTP request updates. We start by adding the Marco update, which indicates this method can modify state and requires consensus from the Internet computer network. Inside our function, we call counter-handle. This delegates the request handling to our counter implementation with authentication. Let's look at our authentication function. The authcheck function takes headers from HTTP gateway and validates them. It iterates through the headers looking for an X-API key header that matches our stored API key. This ensures only authorized clients can access our MCP server. This security layer is essential to protecting our MCP server from unauthorized access. Before we dive into the implementation details, let's understand the core interface that every MCP server must implement, the handler trait. This trait defines three essential methods that form the foundation of any MCP server. Let's examine each one. First, we have the callTool method. This is where the actual tool execution logic lives. When a client requests to use a tool, this method handles the request and returns the result. Next, the listTools method provides tool discovery. It returns a list of all available tools that clients can call, along with their descriptions and schemas. Finally, the getInfo method provides server metadata. It tells clients about the server's capabilities, version, and other essential information. These three methods work together to create a complete MCP server interface. The handler trait provides default implementations, so you only need to override the methods you want to customize. Now let's implement the getInfo method for our counterexample. This method is where we define MCP server metadata. AI agents will prefetch this information before interacting with the MCP server. We return a server info object that contains several key components that help AI agents understand our server's metadata. The server info field provides basic metadata. We also include instructions, a human-readable description of what our server does. This helps AI agents understand the purpose and functionality of our tools. Finally, we use default method to fill in any remaining required fields in the server info struct. This ensures our implementation is complete and follows MCP specification. This metadata is crucial for MCP clients to understand what they're connecting to. AI agents will use this information to make informed decisions. Next, let's implement the list tools method for our counterexample. This method defines what tools our MCP server provides to clients. We return a list tools result containing a vector of tools. Each tool has a name, description, and schema. For our simple counterexample, we define two tools, increase and get value. The increase tool increments our counter by 1, while the get value tool retrieves the current counter value. Each tool is created using tool.new with a name, description, and schema. The schema defines the expected input parameters. In this case, both tools use empty object since they don't require any parameters. This method is called by MCP clients to discover what tools our server provides, enabling them to present available tools to users. Finally, let's implement the call tool method for our counterexample. This is where the actual tool logic is executed. We use a match statement to route requests to the appropriate tool based on the tool name. For the increase tool, we access our counter-thread local variable and increment it by 1. For the get value tool, we retrieve the current counter value and return it to the client. If an unknown tool is requested, we return an error indicating the tool wasn't found. This method demonstrates how MCP servers can maintain state and provide meaningful functionality to AI clients. The thread local storage ensures our counter persists across requests within the same canister instance. Let's walk through a live demo to see our MCP server in action. First, visit the GitHub repository to review the example code and instructions for running the server. Next, we'll deploy the MCP server using the Internet Computer Playground. After deployment, open Visual Studio Code. Add the MCP server configuration to your mcp.json file. Once the settings are saved and the server is started, Visual Studio Code will automatically detect the tools we've defined. Now let's test some tools. Try calling the increase tool to increment the counter and use the get value tool to check the current counter value. You'll see how AI clients can interact with your MCP server in real time. This demo highlights how easy it is to deploy, configure, and interact with MCP servers on the Internet computer.